some algebra in the background. So this problem is going to be about a rectangle. Let's draw a rectangle out for ourselves. And it says that the length of the rectangle is 1 centimeter less than twice the width. So we don't know what the width is. Let's label that with a W. But we do know what the length is. The length is 1 less than twice the width. So in other words, you take the width and you double it, and then you subtract 1, and that's going to be the length. Excellent. So we have a good diagram now. It also says that the area is 45 square centimeters. So of course we know that the area of a rectangle is in general length times width. So in our problem, our area is 45, our length is 2w minus 1, and our width is w. So now we're in a situation that we have a quadratic equation that we can use to solve for the width. So distributing on the right yields 2w squared minus w. Subtracting 45 from both sides yields 0 equals 2w squared minus w minus 45. And now let's see if we can factor this monster. Let's see, 0 equals 2w and w, and we need let's see, a 45 and a negative 1. Oh, so that would be minus 5 and then plus 9. Right? Get a 9w in the middle, and we get the minus 10w on the outside. So therefore, by the zero product property, w will be either negative 9 halves or positive 5. But recall, these are supposed to be widths and lengths, so they're going to be positive numbers. Let's get rid of that negative 9 halves. So coming back to our diagram, I guess we're finding out now that the w is supposed to be equal to 5, and the length is 2 times 5 minus 1, or 10 minus 1, or 9. So the dimensions are length equals 9 and width equals 5. Okay, why don't you try to do one of these on your own? Pause the video and see if you can do this problem. And assuming you paused the video and tried it out, let me do it here with you. Again, we have a rectangle, and this time we have that the area is 33 square meters, and that the length is 2 meters more than 3 times the width. So again, we don't know the width. Let's label the width. We also don't know the length in terms of numerical values, but we do know that the length is 2 more than 3 times the width. So now we can use that information, bring it together into an area equation. Let's come over here and find the area. So the area is generally equal to length times width. So in our example, 33 is equal to the length, which is a 3w plus 2, multiplied by a width, which is a w. So then, if we distribute, 33 equals 3w squared plus 2w, and then subtracting 33 would say 0 equals 3w squared plus 2w minus 33. Now, take our shot at factoring. We need a 3w and a w, and let's think what we're going to do here. Well, it looks like an 11 and a 3, right? So we're going to plus 11, because that'll give me 11w, and then we'll minus a 3, because that'll minus 9 and leave me with 2. So there you go. So by zero product property, w is either equal to negative 11 thirds or positive 3, but of course it can't be a negative value since it's a width, so the width will be equal to 3. So coming back up to our dimensions here, it looks like our width on the left is equal to 3, the width is 3, and what is the length? The length is 3 times 3 plus 2, 9 plus 2, or the length is equal to 11.